Today's real-world databases are highly susceptible to noise. There are missing values and there is inconsistent data. This is due to typically a huge size, and data is likely to origin from multiple resources, and those resources, multiple sources, and those sources are heterogeneous. Low quality data is going to lead to low quality mining results. So we have to think of how can we pre-process data so as to improve quality of our data and consequently quality of our mining results. We have to think of how can data be pre-processed to improve efficiency, ease of mining process. So in this lecture, we shall learn about how to pre-process our data and how to solve these issues. So let's learn. In earlier lecture, we learned topics which were related to statistical description of data, and the topics were mean, median and mode. When we pre-process data, something like filling up the missing values or replacing an inconsistent data with a new data, we compute central tendency, and the measures of central tendency we learned were mean, median and mode. We also learned in which case one of these is to be used, and that depends on whether our data is symmetric or skewed data. And if it is a skewed data, then whether it is a left skewed or a right skewed data. We have defined data mining as it is a process of discovering interesting patterns and knowledge from large amount of data. And these data sources can be either databases, data warehouses, from web, some information repositories, and sometimes it is online streaming dynamically. And as we just defined that data pre-processing is required because data is generated from various heterogeneous sources, and those sources could be one of them. Let us discuss one more term, which is KDD, which stands for knowledge discovery from data. Many people in literature refer data mining as a term used as synonym for this popular term, which is knowledge discovery from data, sometimes also used as knowledge discovery from database. In this term, in KDD process, data mining is used as one of the essential steps of process of KDD. The knowledge discovery process is I have shown on the next figure, where you will see that data mining is one of the steps of the process of KDD. In literature, when you refer variety of books, you will come to see that KDD and data mining sometimes are used as one common terminology, sometimes as a two different. Look at this figure. This is a figure which is used generally to describe a process of knowledge discovery from data. This figure is taken from a book, Hand, Camera and Pay, which we are going to refer for our curriculum. As an iterative sequence of these steps which are shown in the figure, starting with data selection, where data relevant for analysis is retrieved from data warehouse. Then next step is data pre-processing, which we shall be learning in the today's lecture and the next forthcoming lecture, where we pre-process our data and we make it ready for data mining. Data transformation is the next step in which data is transformed and consolidated into a forms that are appropriate for mining. And data mining here is shown as one of the steps of KDD process. This is why I said alternatively the word data mining and KDD are used in the literature. And when we define data mining as independent, then we use the same steps for completing a data mining process. And here we see that next process is interpretation and evaluation, and from which we extract knowledge, which is the final goal of a data mining process. We shall be learning all these steps throughout this lecture series. From today we are starting with pre-processing, and some primitive preliminary terminology we have learned earlier. So data pre-processing. In today's real world data, they are highly susceptible to noise. Many values are missing, some values are inconsistent. This is why sometimes such kind of data in literature is also referred as low quality data or a dirty data. There are many reasons why this data in real world is not a quality data. Why do we say that the data is a dirty data? Another important thing why we need pre-processing is the data is of huge size. It is many a times in petabytes or terabytes. This data is generated from various sources and those sources could be heterogeneous. The data which is collected from various sources is often inaccurate, incomplete and inconsistent. This low quality data is going to result in low quality analysis. So we need to pre-process this data so that we get quality results. And the process of this pre-processing in literature is also named as data cleaning. So data cleaning also stands for data pre-processing. Topics which we shall learn for data pre-processing are many, of which today we shall learn about why do we need data pre-processing, what refers to quality data, and we shall learn about two data pre-processing techniques. One is data cleaning. As I said that the whole pre-process is also termed as data cleaning, and when we remove noise it is also called as data cleaning, and another term is data discretization. So these two we shall be learning in this lecture. As we just termed that the data which we wish to analyze for using data mining techniques is generally incomplete. Incomplete means lack of values for some tuples, or it could be some attributes which are of interest for processing. Inaccurate or noisy. Inaccurate or noisy data is the one which contains error or which deviates from the expected values. And inconsistent data is the data which contains discrepancies. We shall be learning about what these terms means with some examples. But this is a reality and this is a real world data. So it is often said that welcome to a real world. This is an example. This table shows on left hand side the terms which we just recently used, which is incomplete data, inconsistent data and incorrect data. And these are the examples in a second column. So first one, incomplete data. We just defined what is incomplete data. Incomplete data is data where few of the tuple like attribute values are missing. So some records of employers in which there were three attributes: salary, age and weight. So in this data of employees, these three attribute values are often missing. There are few who do not disclose their weight, or maybe the weight at the point of when the data entry was done, when I was filling up my form, I was not knowing about what is my current weight. Second, age. Maybe I am not interested in disclosing my age, so sometimes the age field is left empty. There are many who do not want to write their salary, so these fields are left empty, and such data we call as incomplete data. Similarly, inconsistent data. In inconsistent data, there is a discrepancy or there is a variation between the expected data and the data which is filled in. So one example here is age. If someone mentions the age as 5 years, whereas the person's date of birth is born in 1990. So this is said to be an inconsistent data. This data is inconsistent with respect to this particular another attribute. You can easily find out that a person with this age cannot have, sorry, this date of birth cannot have an age of 5 years. Incorrect data. For the field, say salary, the data which is filled in is minus 5,000. This is an incorrect data. Name field is filled in with something like 123. 123 cannot be a name of a person. One very common example of incorrect data is date or month of date of birth is taken as a default field, which is 1st of January. Or default gender, when you fill in the data, there could be a values a list where male or female is to be selected. Male is default value and the people go in with the default values. So this is these are the some simple examples of what we mean by a dirty data. For examples as incomplete, inconsistent and incorrect data. Now there are many reasons why we get a dirty data when we get it from variety of sources. And this data which is incorrect is to be preprocessed. Data is inaccurate, which we say in other words is having incorrect attribute values. There are many possible reasons for inaccurate data. The data collection instruments may be faulty. Often in the field of today's IoT world of IoT, or when we have an interface of electronic or some devices, we have some data collection devices, maybe temperature measurement device, maybe humidity measurement device. When they are connected, they capture the data and they send it to server. In that case, if the instrument itself is faulty, the data collection is going to be faulty. Often there are humans who enter the data, and there are human errors which make the data entry wrong. Then users may purposely submit incorrect values. Something like, as we just discussed in earlier table, salary mentioned was minus 5,000. This was incorrect data. So sometimes human who's entering the information, their own information, when they are filling in the field, some fields are purposely left empty. Some fields purposely is incorrect, inconsistent data is filled in. Sometimes they choose, as we learned, a default values. This is known as either missing information or inaccurate or inconsistent data. And errors in, sometimes there are errors in data transmission. So during data transmission, there could be some problem with buffer, and then a limited size of buffer. There could be some issue of synchronization, and then there could be a data which is a dirty data. So these are some simple reasons of having a dirty data. One of the reason could be a variability in formats. When you are filling up your height, somebody may fill it in terms of inches, someone may fill it in terms of centimeters. In this case also, what data we get, we say that it is inaccurate, because we will be using one field, one unit. Let's say I am using a centimeter field. Then somebody writes height in terms of 163 centimeters, and someone says 5 inch and 5 feet and 1 inch. Then we feel that this data is incorrect. So what exactly makes data a quality data? How do we define that data is a quality data? It is well said that data that are to be mined should be a quality data. What defines data quality? The data set is said to be of high quality if it is correctly representing the real world construct to which it is referring to. One of the American Quality Control Authority, Joseph, has defined high quality as data as if they are fit for their intended use in operations, decision making and planning, then it is a high quality data. We are going to define quality data in terms of 5 measures: completeness, validity, consistency, timeliness and accuracy. We shall be learning about these terms. What do you mean by completeness, validity, consistency, timeliness and accuracy? And most important is bad quality data may lead to inaccurate and slow decision making. So we need to pre-process data to make it up to some mark of quality data. We shall define data quality in terms of these 6 terms, 6 measures, which are timeliness, completeness, consistency, conformity, accuracy and integrity. Let's learn these terms. Accuracy. We are well aware of the term accuracy. Inaccurate data is sometimes also referred as a noisy data. We just learned negative value at salary, numeric value for the field like name are referred as inaccurate data. Consistency and accuracy, you must remember that they are tied up very strongly. So let us define the term accuracy. Closeness of measurements to the true value of quantity being measured is termed as accuracy. We say that something is 100% accurate is, we were expecting, let's say some temperature today as, let's say 30 degree, and some instrument also measures it as 30 degree, then we say that the results of this particular instrument which is used for temperature measure is accurate. 100% accurate. It refers to whether the data values stored for an object are correct values. To be correct, data values must be right values and must be representing in consistent and unambiguous form. This is why I said that consistency and accuracy are the terms which are tied up very strongly. Inaccurate or noisy data is one of the reasons for getting error or inaccurate mining results. So we need to correct those. So values that deviate from the expected values is said to be an having values with error or inaccurate data. The next term which is to be learnt is completeness. We often ask a question something like, is all the required information available? Do the data which we are using having any elements which are missing? This refers to completeness. So completeness is defined as expected comprehensiveness. So sometimes in some data, we may find some values are missing. Do that mean that it is an incomplete data? No, not necessarily, because sometimes there are some fields which are optional. And even if optional data is missing, but expected values are complete, we say that data is complete. As long as the data that meets our expectation, then the data is considered to be complete. A measure of absence of blank, which are nothing but null or empty string values, or preservance of non-blank values is what we are referring to are missing values. Let's take an example. A customer's first name and last name are mandatory, but middle name could be optional. In this case, even though a middle name is missing, we treat that data as a complete data. Let's learn our next term. Next term is consistency. Now, what exactly consistency means? Consistency refers to the term that data across all systems reflect the same information and are in sync with each other across the enterprise. We just learned one term, that height is measured, somebody is writing in terms of centimeter, whereas somebody is writing in terms of feet and inches, then it is not said to be a consistent data. It could be a temperature measurement. Somebody is writing in terms of Fahrenheit, somebody is measuring and writing in terms of Celsius. The absence of difference when comparing two or more representations of the things against the definition, we refer it as inconsistency. Example is a business unit status is closed, but there are cells that are business units. This is something like, let's say one of the branch is closed, but a central server is still showing that in last week these are the transactions which happened in that unit. This is also inconsistent data. Employee who has been already terminated, but his pay status is showing that a salary is paid. This is inconsistency. So inconsistent data is data where it contains some discrepancies. This is about consistency of a data, which is one of the quality measures. The next term which is used for measuring a quality of data is timeliness, one of the important factors. Timeliness depends on the user's expectation. Online availability of data could be required for some room allocation system in hospital. But current information, if it is not available, then there could be some issues about allotting a room for a patient. A degree to which data represents reality from the required point of data is a measure of timeliness. Timeliness references whether information is available whenever it is expected and needed. So when information is required at that particular time, a correct information should be available. That is timeliness. Timeliness of data is one of the important factors for measuring quality of a data. Companies that are required to publish their quarterly results within a given frame of time, but they are not published in that particular time frame, then it is not a timely data. Customer service providing up-to-date information for the customers. Credit system checking in real time, referring to accounts availability or some activities, some transactions is timeliness. Next term which is to be learned for measure of quality is Integrity is one more term which is referred for measuring a quality of a data. Data are valid if it conforms to the syntax, that is format, type, range by its definition. For every data, there is a metadata available where often information about its syntax in terms of expected format, type and range is defined. If we enter a data, if the data is available with respect to this syntax which is defined in terms of format, type and range, then we say that that data is valid. Believability reflects to how much the data is trustworthy by users. Integrity means validity of data across relationships and ensures that all data in database can be traced and connected to other data. When we integrate data together from variety of sources, then it is a major requirement that it must be following a common syntax. Otherwise, integration of data from various sources becomes difficult. And if it is following the required syntax, we can integrate it together, then that data becomes a trustworthy by the users. Let's look at one example about a customer database. In customer database, there should be a valid customer, its address and relationship between the customer and its address. If there is an address relationship in the data with some customer, and if that customer is missing, then that data is said to be a data which is not valid. So this integrity is one of the key term which defines quality data. The next term which is to be learnt is conformity. We often ask question about data values. Do data values comply with the specified formats? If yes, then do all values comply to those formats and so on. This is said to be a conformity. Interpretability reflects how easy the data are understood. Conformity means the data is following the set of standards, data definitions like data type, size and formats. Some typical examples is date of birth of customers. Sometimes we follow terminology MMDDYY, sometimes it is DDMMYY. So maintaining conformance to a specific format is nothing but conformity of data. So this all discussion was regarding why we need data pre-processing. So we learned that for data mining, what we do is we analyze a huge data, we try to extract some patterns, we extract some interesting patterns, we get a knowledge out of it, like if we arrange these items next to each other, if we launch a movie in month of, let's say, Diwali, then there could be a good response. Some kind of knowledge we get out of from data after data mining, and then we take some wise decisions to improve the business or some other goals. In this data mining, the input to data mining algorithms is data. And if that data is inaccurate, if it is not a quality data, then we don't get a quality results. As data is used, it may take a slow process and it may result in inaccurate or not the interesting patterns. For this reason, we need to pre-process our data so as to make it a quality data. So what we learned now was what are the reasons of having a real world data which is a dirty data, and how do we define that our data is a quality data. Now we need to learn about, if we want a quality data, then whatever is real world data is to be pre-processed. And how do we pre-process data so as to make it up to expectations or a quality data. So let's learn about what are the major techniques which are used in data pre-processing. Commonly used major tasks in data pre-processing are these. First one is data cleaning. In data cleaning, what we do is we fill in the missing values and we try to smooth the data because there is some noisy data existing. Second one is data integration. where a correlation analysis is performed for data integration. Then there is one more term which is to be learnt is data reduction. In data reduction, we are going to learn about two: data cube aggregation and attribute subset selection. There are many techniques, but we will be concentrating on these techniques. These are the part of our study. We will be learning these. Next term which we will be learning is data transformation, where we will learn about normalization. We will be learning about min max and z-score normalization. And the last one is data discretization, where we learn binning techniques and we learn about histogram analysis. In today's lecture, we shall be learning about data cleaning. We just discussed that real world data tend to be incomplete. It could be noisy or it could be inconsistent. Data cleaning routines attempt to fill in missing values or smooth out the noise by identifying outliers or replace inconsistent data with some new data. We also learned that there could be many reasons of having dirty data, which could be because of instrument fault, maybe human error, maybe transmission error, or maybe any other reason. In data cleaning, what we do is we try to detect and correct the corrupted data, which is nothing but maybe inaccurate data, maybe incomplete data. And when we do this, we either replace it with the new values, or we modify the existing values, or we delete those values. So let's learn how do we do it. In data cleaning, there are major two important aspects which are handled. One is missing values and the second is noisy data. Now, what do I mean by missing values? When there are no values stored for any particular attribute, then we say that it is a missing value. We call some data as a noisy data if it is having a value which is not relevant, which is not consistent with the other values, then we say that it is a noisy data. Like when, let's say now when we were recording this video, in audio, if some external voice, external some noise gets added, then we say that today's audio is a noisy audio, and so on. This data in which the values are missing is also referred as a incomplete data. Data, when it is not always available, when it is not complete data is not available, that also we refer as incomplete data. Examples we learned. One more example is customer income is not recorded. Salary, people do not mention how much salary they are getting. When we fill in the general information, let's say it is registration at some site, it could be registration for some course, people do not fill in one of the fields which could be a salary field. Though it was a field which was compulsorily to be filled in, then they may mention something like 000s, they may mention some different values, or they keep it unfilled, then we say that the values are missing. Missing data could be because of many reasons. As we learned earlier, it could be because of equipment malfunctioning. Maybe inconsistent information was recorded and then it was deleted, so that those fields. So let's something like salary was mandatory field to be filled in, so I fill in 000. I fill in minus 5,000. And then at other end, by some human who was integrating that data, who was collecting that information from various sources, deletes all such records, such values, then they are said to be blank values, which will be a missing data. Data was entered, but it was misunderstood by the person who was working on that data, and he deletes that information. In that case, you may find that that data was empty, or it was the missing values. At the time of entry, I feel that this information isn't that important. So we omit that information, so it becomes missing records at some other location where it was again integrated with some other database, and so on. So these are the reasons why there are missing values in data. Now, how do we handle these missing values? Missing data can be handled in multiple ways. We are going to learn these 6 ways of handling the missing data. First one is ignoring a tuple. Second one is filling up those missing values manually. We shall learn all this one by one. Let's look at one of the most common approach followed for handling missing data is simply omit them. Simply omit the cases where missing data is noticed. So when you omit it, what we do is we either omit a whole record which has missing values, or a complete attribute which has maximum missing values is omitted. But this is suitable only when we have huge number of samples recorded. That is, we have a database or particular data set in which number of records are sufficient to be processed and extract the patterns. If the data samples itself are lesser, then this approach doesn't work. Look at this. As we learned, there are two approaches. Either we can delete a whole tuple or we can delete a whole attribute. This is one where these are the attributes which are missing. This was a missing value. Then this is the missing value. So if you look at this seventh tuple, then both the attribute values are missing. Only third one is available, and here one value is missing, and here also one more value is missing. So when we simply delete these records, so we are going to delete the record, this one, then two, and the last one, and the resultant table will be like this, where the tuples which had missing attribute values are simply omitted. This is where the maximum attribute values are missing. So what we can do is we can delete this whole attribute and the resultant data will be as this. Missing values, omitting the missing records or attributes seems to be very easy way of handling the missing data. But there are many pros and cons which are related with this ignoring the missing tuples or attributes. This particular approach is generally used when class level is missing, assuming the mining task involves classification. Now we haven't yet learned about what do you mean by supervised learning, what is unsupervised learning, the terms which we haven't learned, like what is classification, what is clustering. There it will be more clear what we mean by what is the drawback of using ignorance in supervised learning. This method is not very effective unless the tuple contains several attributes with missing values. In earlier two tables, we saw that in one of the attribute, more than 50% values were missing. So we have to decide when to ignore it. If maximum values are missing, then we decide that let us omit a whole attribute. It is especially poor when percentage of missing values per attribute varies considerably. Then it becomes very difficult to decide which attribute to omit and which attribute to keep, because they are relatively, one has more missing values and other has less missing values. By ignoring the tuple, we do not make use of remaining attribute values in the tuple. What we do is we simply omit it. We are not looking at the existing values. We are not taking benefit of some values which were present. We simply omit it. It may happen so that the values which were recorded may be of some use in our analysis. But what we do in ignorance is we simply ignore all the values. We will be learning about what is classification, supervised learning. Supervised learning is basically a synonym used for classification. The supervise on a learning comes from labeled examples in a training data set. For example, in postal code recognition problem, a set of handwritten postal code images and their corresponding machine readable translation are present and they are used for training. In such kind of case, the training modeling is referred as supervised learning used for classification modeling. We'll be learning all this later. Next way of handling missing values is filling those values manually. As it refers, it is not a feasible solution. If missing values are to be replaced by some unknowns, then this task can be done by a human or some known values. This can be done by human, but it is not a foolproof technique. It is time consuming, as we learned that the data is huge and it is not feasible when many values are missing. Person cannot fill in and may not be the values which are filled in are correct. Often it is done by something like a global constant is used to fill up the missing values. In real life also we observe, I have come across many people whose uh, date of birth is 1st of Jan. Because the date of birth was not known, it is by default the 1st of Jan. Because the date of birth was not known, most of the people are given date of birth something like 1st of July, because it was required to fill in a registration form for admissions at the school. This is old days issues, and such are called as use of global constant to fill in the missing values. Next way is to use a central tendency as a measure to fill in the missing values. Measure of central tendency indicates a middle values in a data distribution. In this technique, goal is to replace missing data with a statistical estimate in terms of either mean, median or mode. For normal data, which is symmetric data distribution, the mean is preferred, while in case of skewed data, median is preferred. In earlier lecture, we have learnt about these terminologies, and we also discussed one example which was with respect to a salary of customers. Also, marks of students obtained in the class. When the data is symmetric, mean income was used to replace the value. If some value is missing, then the mean salary of the employees was 56,000, and it can be used for replacing the values of the fields where the value is missing. This table indicates that mean is used. So these are the values which are missing. These are the missing values, and these missing values are filled in with the mean value. 130 is mean, and that is placed at the missing attribute location, and it comes out to be 130 here and 130 here. This is when median is used. When data is skewed, median is used, and median in this data when sorted is 155, and that is used to fill in the missing values. So 155 is placed at these two missing values, and resultant table is this. Mode is most frequent item. Mean is average of all the values. Median was the middle value, and mode is the most frequent value. If you look at these values, you will find that 200 appeared more number of times. So it is a mode of this attribute, and the missing values are filled in with mode. Next way of handling is use mean or median samples belonging to the same class. As we just learned that we are going to classify whole data into number of classes using supervised learning for a level data, and in that case whatever is mean of one particular class is used to replace the missing values, and similarly median. This classification term clustering, these all we are going to learn later. First five we discussed for handling missing data, and sixth one says that we should predict a data which is to be filled in for the missing values. It means fill in with the most probable value. And for this, regression analysis or decision tree induction is used, which we shall be learning later. There are many pros and cons associated with these different techniques which we discussed. By considering attribute values in its estimation, let's say income, there is a greater chance that because of some values which were too less or too high, it may affect mean which we had computed. We had learned this in earlier lecture that if there is an outlier, something like a very high salary, very high score in the class, a low salary or a low score in the class, then it may affect the mean. And we have learned that in that case what we use is we will be using a trimmed mean. So method 3 to 6 bias the data because we fill in the value and that value may be incorrect. In method 6, however, though it is a very popular and correct, we need to predict it using the techniques which we shall be learning later. This was all about missing values. The next kind of problem associated with real world data is the noisy data. Information that is irrelevant is also referred as noise. Unfortunately, there is no precise definition for outliers or a noise. An outlier is a simply data which does not fit in with the other data, which we say that which is not relevant to, which is not inconsistent with, which is not same as the others are. Then we say it as a outlier. In case of class score for a particular test, let's say a set of students marks vary between 40 to say 70. All the students in class out of 80 students, say 79 students have scored marks ranging from 40 to 70. And one student scores marks, let's say 94. Then we call it as something which do not fit in the earlier range. So we call it as an outlier, and it is not necessarily always a noise, but in our common analysis terms, we call it as an outlier. An outlier can be a valid data point, and it may not be always a noise, but sometimes it could be a noise. Some person, let's say in class, we are taking reviews of say online lectures, and say that out of 80 students, 79 are saying that it is excellent and one person says that it is very very poor. Then that one particular review we treat it as a noise, though it is not necessarily a noise, but we treat it as a noise. One high or very low score in the class, one high or very low salary among the employees could be treated as an outlier. Sometimes it is really a noise. For example, somebody filling in information or applying for the post of, let's say, a software engineer, and he is mentioning his experience, and the experience mentioned is something like 150 years, then it is a real noise. And these noise, which is variance with respect, can be measured in terms of variance, could be because of many reasons. It could be faulty data collection instruments, it could be data entry problems, it could be data transmission problems, technology limitations, or some inconsistency in naming conventions. But for any reason, it will be treated as a noisy data and we need to correct it. How do we handle this noisy data? There are many techniques, of which we are going to learn two techniques. First one is binning. Now what is binning? Binning methods are used to smooth the data, and binning methods smooth sorted data values by consulting its neighborhood, that is the values around it. It is believed that the values in neighborhood are said to be like consistent with each other, and so we refer to the near neighborhoods to decide whether the current value noise is to be, how it is to be handled. The sorted values are distributed into buckets or bins, and then smoothing is performed based on techniques something like use mean, median or mode, or use boundary values. How it is done? Let's see. Binning is a process where we try to smooth the data. Now how exactly we do it? Binning method uses a sorted data and it consults neighborhoods. While referring to neighborhood, while smoothing the data, each bin is replaced with its mean or median or mode. When we use a mean, then it is said as binning with mean. We can bin with median and we can also bin with boundaries. When we bin with mean, we replace all the values in that bucket with the mean. When we bin with median, we replace all the values of that bucket with the median. Sometimes this is done with the bin boundaries too. So when we do it with bin boundaries, what we do is we replace all bin values with the boundaries, that is minimum or maximum value in the bin. This minimum and maximum values in the bin are bin boundaries, and each bin value is replaced with its closest value. That is either minimum value or a maximum value. Let's look at these two tables. This is showing example. This is an example of binning. In bin 1 we have these values. In bin 2 these are the values, and in bin 3 these are the values. When we smooth this bin with the means, what we do is we compute the mean of these four values, that is 2 plus 3 plus 6 plus 8 divided by 4. The mean comes out to be 4.75. And what we do is each of this bin is replaced with the mean value. So this is said to be a smoothing because all of them are at same level. Smoothing as the term itself is descriptive enough. What we do is there are some values which had lower uh, values, some were higher values. When we smooth, they all come at similar range. That is same value. They are replaced with the same value. So the one which was lower is increased by some value, and the one which were higher are decreased. This is called as smoothing. So how is this performed? What we do is we sort the array initially, that is each bean. Then we divide a whole data set, we sort it, then we divide into equal intervals, say n. Here this was the data and we have divided into 3 bins, so equal 3 bins of size 4. And then this is called as equal length partitioning or equal depth partitioning based on how we partition it. And then we store either mean, median or boundary at each value, and that is called as binning, or it is also called as smoothing. Noisy data is smooth. Here there were much variation, 2, 3, 6, 8. 2 was comparatively much smaller as compared to 8. So what we consider that this is a noise, and we smooth it by replacing with a mean. So binning is also termed as data smoothing, where what we do is bean is replaced, all values are replaced with mean. When the values were 4, 8 and 15, its mean is 9, so what we do is we replace all the values with 9. This is called as smoothing by bean mean, smoothing by bean median. It could be smoothing by bean boundaries. This is smoothing with bin boundaries. Let us look at one example. We have set A with these values 1, 2, 2, 3, 5, 6, 6, 7, 7 and 8, 9. Minimum and maximum values of each boundary are initially identified, and then each bin value in that bin are replaced with its closest boundary value. We need to define a interval width. If we want to have 3 bins, then the value of k will be 3, and we compute it as max minus min divided by k to decide what is going to be a bin width, and we get a value as 2.7. So bin intervals become 1, 3.7, then 3.7 to 6.4, 6.4 to 9.1, and each value will be replaced with the one value which is closest to it. Each bin value is replaced by closest boundary value, to be very specific. So initially we get these 3 bins. First bin with values 1, 2, 2, 3. Second is 5, 6, 6, and third one is 7, 7, 8, 9. And depending on which is the closest value, the values are replaced with. So we get a resultant bin for first bin after replacing with bin boundary as 1, 1, 1, 3. Second as 5, 6, 6, and so on for the third one. This is smoothing by bin boundaries. Binning is used, as we learned, for data smoothing. And let's take another example where we have a sorted data for prices, say in dollars, represented as set B with these values 4, 8, 9, like this up to 28, 29, 34. If we use smoothing, with mean we get what values if we use boundaries, and if we use median, then what are the resultant means are shown here. When we use smoothing with mean means, the resultant means are as this. Just like in earlier cases, we are going to divide into beans and then we'll replace it with a bean mean. So initially we'll have the first bean as 4, 8, 9, 15. Then we compute its mean, which comes out to be 9, and all the values are replaced with 9. Similarly, for second bean, replace with 23, third replace with 29. This is beaning for data smoothing with the help of mean. Similarly with bean boundaries. These are the resultant bean boundaries. As in earlier example, we divide into beans first and then we decide the interval and then we replace each value with the closest value. Similarly, the third is beaning with median. For first case 4, 8, 9 and 15, 9 was median. So all values are replaced with median. Here median 24 is used to replace and then 29. So we learned that data preprocessing is necessary to handle the real world data, which is we call as a dirty data, which is not a quality data. And quality data leads to quality decisions or quality results. So we need to pre-process it. First technique for data pre-processing was data cleaning, which was used to handle two kinds of issues. One was missing data handling and second one was noisy data handling. And we learned how to use mean, median, mode or bin boundaries for handling the missing data, or in binning process to replace the all values to smooth the data so as to remove the noise with the help of mean, median or the boundary values or the mode. The next task to be learned is data transformation. Data transformation, as the name suggests, data are transformed or consolidated, more specifically consolidated into form which is appropriate for mining. We'll be learning how this is done. There are 6 ways to do data transformation. First one is smoothing. In smoothing, it works to remove the noise from data that we just learned. We learned how binning is used for data smoothing. The smoothing includes variety of techniques. One of them is binning. Second is regression and clustering. Regression and clustering are the terms which yet to be learned. We learned about how binning is used for data smoothing. Attribute construction, or which is also known as feature construction, where new attributes are constructed and added from a given set of attributes to help the mining process. This is the next term, attribute construction. We'll be learning, all are not part of our curriculum. Those which are part of curriculum will be learning. So attribute construction is one where a new attribute is constructed or added in the given set of attributes using a mining process. Aggregation is the next task. Aggregation, where the summary or aggregation operation is applied to the data. For example, daily sales data may be aggregated so as to compute monthly and annual total amount. This step is typically used for constructing data queue for data analysis at multiple abstraction levels. We shall be learning this. Next term is normalization, where attribute data are scaled so as to fall into a smaller range, which could be -1 to 1 or it could be 0 to 1. We shall be learning this. Data discretization is the next. Data discretization is the process of converting continuous data into discrete buckets by grouping it. Concept hierarchy generation is used for nominal data where attributes such as street can be generalized to higher level concept like city or country. Many hierarchies for nominal attributes are implicit within the database schema or can be done automatically. We shall be learning these terms, and some of the terms some of the terms will be learnt in the next lecture. Data discretization, we just defined that it is a process of converting continuous data into discrete buckets by grouping it. Let's see how. Data discretization converts this continuous data to discrete buckets by grouping it. Data discretization is going to convert large number of data values into smaller ones so that data evaluation and management becomes easy. Look at this table. We have an attribute age with such values, and we can group them into some names such as young. So a range of age between 10 to 19 is grouped as something young. So all the age groups which range between this will be termed as one common bucket, which is young. These values from 30 to 42 will lie in one range, one bucket, and we'll call it as a mature age. And age ranging from 70 onwards, we can name them as older people or elderly people. So data discretization, what we do here is we combine the values together and we name it with one common title as given to one bucket. Now, why do we go for data discretization? We just named that it is going to convert the continuous values to discrete. So let us take one example of continuous variable as weight. And we have some values below 100, lying between 140 to 160, and above 200 can be named as lightweight, midweight, and heavyweight. And this helps us easy to understand this continuous data like a weight when divided and stored in meaningful categories or groups. There are many data discretization techniques, of which two we are going to learn. One is binning, we have just learned, and the next is histogram analysis. And we shall be learning histogram analysis in the next forthcoming lecture. These are few assignments which are to be solved by you based on the today's contents. There are 4 questions given. These are the values given, and you have to use binning and different binning techniques and partitioning techniques for data smoothing. So to summarize, real world data are often dirty. For accurate results, data has to be pre-processed. Quality data is going to lead to quality outcome. And we have defined data quality in terms of accuracy, completeness, consistency, timeliness, believability, and interpretability. Data pre-processing techniques involve in all data cleaning, integration, reduction, transformation, and discretization. We have learnt about data cleaning, which is a process of detecting noise and inaccurate data, missing and noisy values, and correcting them. Topics that we shall learn in next lecture is, we shall continue with the data transformation. We have learnt about what is discretization. We'll be learning about the most popular technique used for data transformation, which is normalization. And the commonly used techniques are min-max normalization, z-score normalization, and sometimes decimal scaling. And we are also going to learn about what is histogram analysis.